Today and tomorrow we are going to talk about delegates. And delegates are an advanced topic that we are just going to barely scratch the surface on. In fact, it would be suited for an advanced course on C#, which is something that we very well might do. But I think it's important to introduce you to delegates because we can do so many cool things with delegates, especially whenever you get into Windows development, which is event-driven. Events are based upon delegates, so you would be using delegates all of the time. So, at least with an introduction, you can get a feel for what delegates are and how you can use them, at least somewhat, within your code. And let's start by first talking about what a delegate is. Well, it is a data type that defines a method signature. Now, we've talked about signatures before whenever we talked about overloads. In fact, it's how one overload is distinguished against another. It has a different signature. So we basically define this new type that is a method signature. And by doing so, we are allowed to pass one method as an argument to another method. So it's very cool stuff. So the first thing we're going to do is demonstrate a delegate. We are going to define a delegate, and then we are going to create two classes, and then we will use that delegate to pass one method from one class to the method of another class. So very cool stuff. So first, let's create our delegate. And in this case, we're going to make it public. And notice it's being listed outside of the class. We could define it inside of the class program, but this is its own data type, so it can be defined inside or outside of a class. We're going to do outside of a class so that it can just be used everywhere, and most delegates are. So we have public, and then we need to use a keyword called delegate. We have a keyword for just about everything. And then we need the method signature. Now I want to keep things very simple, so it's not going to return anything, so we're going to use void. I'm going to call this method sayMessage, but it is going to accept a value, a string value. So that's it. We have just created a delegate. And as such, we have created a new data type called sayMessage. So whenever we want to use this delegate, we will use it by the means of sayMessage. So now let's write a couple of classes. We'll call one class delegate1 for the lack of a better name. And let's just have one method inside of it. We're going to call it method for, once again, the lack of a better name. And it's going to have the same signature as our delegate because the signature is very important. And inside of this method, it's just going to call writeLine and pass message. So we could just simply create one of these objects. Let's go ahead and do that. Delegate1. We'll call it 1 equals new delegate1. And then we could simply just call 1.method and then pass a value. Let's do hello world. Run it, and that's going to work. Now, we haven't used the delegate yet. I'm just showing you that this is just a normal class. There's nothing special about this. Okay, so let's create another class. We're going to call this delegate2. And it too is going to have a method called, for the lack of a better word, method. It doesn't have to be the same name as this other method. In fact, let's just do this, method2. That way there's no confusion between the two. And this is going to accept a method. So we are going to use the delegate that we defined, sayMessage. And notice that we have used it as a data type because I mentioned earlier, delegates are a data type. So this is going to accept a method with the signature as specified as sayMessage. So the signature has to not return a value, and it has to have a string parameter. So whenever we get this method, all we have to really do is execute it and then pass whatever message that we want to. So let's do hello world. Why not? Let's do hello world from delegate2. Delegate2. There we go. Okay, so let's create a delegate2 object. New delegate2. And then we want to pass the method from delegate1 to the method2 in delegate2. So to do that, we would do 2.method2, and we will pass 1.method. And we're not going to call it, so we're not going to execute it by passing a value. We are just going to do 1.method. And then that's really all that we have to do, because whenever method2 executes, it's going to execute the method that was passed to it. And we have provided a string method to execute. So whenever we run this code, we will see the phrase hello world from delegate2. And voila, there we go. So that is a very simple and very quick demonstration of delegates as to how we can define a delegate and then how we can use them to pass one method from one class to a method of another class. But it doesn't have to be from two different classes. It could be one method from one class to another method in that same class. So it's just a means of passing a method to another method. But let's not stop there. Let's look at a real-world usage of delegates. So let's get rid of all of that code and get rid of all of this. And this is going to be a rehash of the code that we looked at when discussing collections and generic lists. If you remember, we had a list of names, and we used the findAll method to find names based upon a certain criteria. And we used a lambda expression to do that, which we will talk about tomorrow. But today I want to use an actual method to do that. So I want to write a method and then pass that method to the findAll method so that that will select our names for us. So we have our names. I just pasted them in. Let's write our method. And it really doesn't matter what method it is. It can be static or it can be instanced. But if it's instance, we have to have an instance to call it on. We don't have that right now for class program. So we're going to make this static. And before we write this method, we need to find out what exactly our method needs to have. So the findAll method has a string, or it accepts a method that has a string parameter. So we need to do that, and we also need to return a Boolean value. So static bool, and then we can name this method anything. So find names with E. It might as well be something that we can remember, and it needs a string parameter, and we'll just call it name. And so inside of it, let's do name index of E equals 1. So any name that has E as its second letter is what we want to select. And this is what our method is going to do. So now that we have our method, we can pass it to the findAll method, find names with E. We don't want to, call it. We just want to use its name, pass it as the argument to findAll, and then we need a variable to contain this new collection that we are going to create. So we'll call this names with E. And then we want to write a loop to write those names, name in names with E, to the console. So console.writeLine name. So we should get 3 names, Jeremy, Jeffrey, and Jennifer. So let's run it. And there we go, Jeremy, Jeffrey, and Jennifer. Now let's review what we just did. We are using the findAll method. And we found the criteria needed. Names, there we go, findAll. We found the criteria needed for the method that's going to be passed to the findAll method. It says predicate string. But this is essentially saying we need a delegate that has a string argument. So that's where we got that requirement from. The Boolean, I just knew what that was. Because we are actually defining the method, it needs to return a Boolean value. And so we defined our method to look at each name, see if its second letter was an E, and if it was, it returns true. If not, then false. If it's true, it's going to add it to our new names with E collection, and then we looped over that collection, writing each name to the console. Now, in ye olden days, this was just one of two ways that we could do what it is that we just did, searching a list using the find all method. There's another syntax that we can use that involves using a delegate literal. So instead of passing a method, we specify delegate. And we don't have to use a return type here. It's automatically done for us, but we do have to have the string parameter. We don't need a semicolon there. And then we just need to copy and paste the return statement that we had before. So it's kind of the same thing, except we're not writing an actual method and passing that method to the find all method. So we've used a delegate instead. And if we run this, we will get the same exact results. Now, what we are going to look at tomorrow is how we can even write simpler code using Lambda expressions. And we're also going to look at functions because we're going into a direction to look at LINQ. And LINQ requires us to use Lambda expressions, but in order to use Lambda expressions, we have to understand where Lambda expressions come from, and that is delegates. So we are going to end today's lesson here, because I figured that this is a great place to do it. We've seen how we can use delegates, but tomorrow we're going to see how Lambda expressions just blew delegates away, and how everything is all puppies and fuzzy bunnies and all that wonderful stuff. So we will talk about lambdas and functions tomorrow.